Flip one switch and 100 things wake at once. Lights, the fridge, the charger by your bed, all of it pulled through wires thinner than a pencil, hidden inside your walls. Push those wires too hard, and they grow hot enough to start a fire where no one can see it. So somewhere in your home sits a small patient guard, waiting for that exact moment. Today we slice one open and watch it save the house. Electricity moves as current, measured in amps. Every wire has a limit. A common home circuit is rated for 15 or 20 amps. Below that line, the wire stays cool and calm. Push past it, and the metal heats up, the plastic insulation softens, and a fire can begin in a place you will never check. The breaker has one job. Notice when too much current is flowing, and cut it off before the wire ever turns dangerous. Open the grey panel on the wall and you find a row of switches. Each one is a breaker, and each one guards a single circuit in your home. The wire from the power company runs in, passes through the breaker, then heads out to your rooms. Everything on that circuit must travel through this one device. Place it in the path like a gate across a single road, and nothing can flow without going through it first. Inside the plastic case, the path is simple. Current enters at one screw, crosses a pair of metal contacts pressed firmly together, then winds through two clever parts before leaving at the far end. While the load is normal, those contacts stay shut and electricity flows straight through, quiet and warm. The whole device does nothing at all. It is built to spend its life waiting and watching one number, ready to move only when that number climbs too high. The first guard is a thin strip made of two metals bonded back to back. One metal expands more than the other when it warms. So as current runs through the strip and heats it, the strip slowly curls to one side, like a green leaf drying in the sun. A small, steady overload, a few amps too many held for too long, makes it lean a little further every second, creeping toward a tiny trigger waiting beside it. If that overload lasts, the strip bends far enough to nudge a latch loose. This is the slow trip, and the delay is on purpose. Motors and heaters pull a brief surge the instant they start, and you do not want the lights going dark every time the vacuum turns on. So the thermal strip stays patient, shrugging off short spikes, and acts only when too much current stays too long. It measures heat, which means it measures time. But some faults are not slow at all. When a bare hot wire touches a neutral or a ground, the current does not gently climb. It explodes, hundreds or thousands of amps in a single heartbeat. For that, the breaker carries a second guard, a coil of wire wound into an electromagnet. At normal current, its pull is far too weak to matter. It simply sits in the path, holding no power over anything around it, biding its time. Then a short circuit hits. That violent surge floods the coil, and for an instant the electromagnet turns ferociously strong, strong enough to yank a small iron lever toward it. That pull trips the very same latch the heat strip was leaning on. This path is nearly instant, acting in a tiny fraction of 1 second, because a short circuit is the most dangerous fault of all, and it cannot be allowed to linger for even a moment. Both guards point at the same trigger, a spring-loaded latch holding the contacts shut against constant tension. Think of it as a mousetrap, cocked and straining to snap. The heat strip can release it. The magnet can release it. Either way, the moment the latch lets go, a stored spring takes over, and the long, gentle waiting ends in one sudden, decisive motion. The breaker stops measuring the current and all at once starts moving against it. The spring drives the two contacts apart in an instant, but electricity does not give up cleanly. As the gap opens, current leaps across it as a searing blue arc, a thread of plasma hot enough to weld the contacts shut again. So the breaker steers that arc upward into a stack of metal plates called an arc chute. The plates split the arc, draw away its heat, and snuff it out. The road is finally truly broken. Out front, the handle has flipped to the middle, quietly telling you which breaker tripped. The circuit is dead, the wire is safe, and nothing is smoldering inside the wall. To bring the power back, you first push the handle fully off, which recocks that spring latch hidden inside, then flip it firmly on. The contacts close, both guards reset, and the patient watch begins again, exactly as it was before anything ever went wrong. So here is the whole chain. Current flows in through the closed contacts. A small, steady overload heats the bimetal strip until it curls and frees the latch. A sudden short circuit floods the electromagnet, which yanks that same latch in an instant. The freed spring snaps the contacts apart, the arc chute kills the spark, and the handle shows you what happened, waiting to be reset. 2 sensors, 1 latch, 1 spring, doing one quiet job. A fire that never started, a wall that stayed cool. All of it from a small switch you almost never think about, sitting in the dark, doing nothing at all until the 1 second it must do everything. Next time the lights drop and the house falls quiet, you will know exactly what just moved inside that grey panel. The patient guard did its job. That is the circuit breaker.